All right, so when you unzip this lab, you're going to see that there is a folder that has a geodatabase and some land and a Landsat folder. Okay, so when you go into ArcGIS, I'm going to connect to the desktop, and I'm going to go into I'm just going to go into the Landsat imagery. And you're going to see that here is a TIFF file, so it's a tagged image format file. So it is the reflectance of the blue wavelength band 1. So I'm just going to add that. And these are pretty big, and they come in as a grayscale. And so here I am looking at that reflectance, and you can see the resolution is not great because these are 30 meter by 30 meter pixels taken by satellites, right? So they just aren't that great. The thing that is the focus of this first part of the lab is for you to look at each of these bands and try to understand what they're used for. So the blue band length is really good for looking at water along the coast. The green looks at vegetation or reflect vegetation. Red absorbs chlorophyll, so that's kind of will show a healthy vegetation. Near infrared, dark water will appear very dark. So it talks a little bit about these different uses of the bands, and then it has you go in and add all 7 bands. So I'm going to add 2 through 7 and add those, and you'll notice that there is one other type, and this is called a composite. So this took bands 1, 2, 3, 4, 5, and 7 and put them together in one color image. And that's what you're going to use for steps 2 and 3. But for this first step, you're going to look at each wavelength. And then the lab asks you to try to identify a feature. So I'm going to zoom out, and I think it gives you some, let's see, it tells you to add, create a scratch geodatabase and to add some highways so you kind of know what things are. So I'm going to go into the highway layer file, and I'm going to add that. And then this is the symbology, but it needs to be pointed to the data. So I'm going to right click this and repair that data source. And I'm going to go, oh wait, back. And I'm going to go find the highway data here. And then I don't have to symbolize it. So this way I can say, okay, major roads, now I can kind of see what things are. And I wonder if it has a file for rivers. Yeah, it does. So it'll kind of show me where water is on this map. Ooh, I'm going to zoom to that. Aha, okay, so there's a water feature. All right, so now I can kind of tell what's a road and what's water, because it's kind of difficult to tell that from just the gray imagery. So if I were to select only this, oh, mine are out of order. I need to move that guy up there. Yeah. So if I want to look at just this blue bandwidth, I can take the Identify tool and I can click this waterway, which is the Potomac, and I'm going to get a pixel value of 64, and that's called the digital number. So in the blue wavelength, water will reflect at a value of 64. If I do it in 7, water reflects at a value of 5. Look how much easier it is to distinguish the water in this thermal band. So if I only had a couple images and I really wanted to pull out all of the water, it would be pretty easy to kind of find that water using this band combination. And then look here, I can kind of see a different color water, and that's water that has some sediment in it. So that's going to reflect differently than clear water is. And I know you guys can't see that very well from, when you watch the video, you'll be able to see that. So the lab asks you to go through and really evaluate different elements using these several different bandwidths. The other thing that you have access to is the image analysis window. And you've got to make sure that your extensions are turned on for, I think it's image analysis, and I'll check on that. I think ours are. Yeah, spatial analyst has to be turned on. So the image analysis window lets me, let's see, I'm working with just that one. I'm down at 7. So it lets me change, sometimes I want to change the brightness or enhance that image a little bit so that I can see other elements. And so this lets you do that. It also lets you crop, so cut a scene so that you're only looking at a certain part of that remote sensed image. So this is a pretty cool thing. So the first part is just kind of looking at the different bands. You're going to add the area of interest that they have here. It's an AOI. And then with the area of interest, going to, I think, number 4 and number 7, and just trying to get a sense of how these different things reflect. And then in part 2, you're going to remove all of these. I lost my table of contents. There it is. You're going to remove all of these, and you're going to add the composite image. Okay, I'll turn those guys off. And I'm going to add that composite. And you just click this. If I open it, I'm going to see all of that as individual pieces, and I just want to add it like this. And this comes in now kind of like an image, right? Red, green, and blue. What's really different about this, when I go to properties, it's going to do something called building the histogram, which means it's looking at the wavelength and the spacing of each of the different images. And I'm going to set this thing to true color, which is red, green, and blue. And that's the way we look at images in real life. So there's an RGB red, green, blue image of this area. And you can see that now I can see buildings and grass and rivers. But if I set this to false color, which is 432, so I'm putting the near infrared in that red gun or red channel so that the near infrared is going to show red. And then the red reflectance is actually going to show green, and the green reflectance is wavelength is going to show blue. Okay, that messes with my head too. Okay, so then I'm going to do that, and what I get now is I don't know if I set that right. Let me look at that. Near 432. Yeah, I think I did that, but let me just double check my settings for RGB. 321 is called true color, and then we're going to do near infrared 432, and that's what I did, right? Properties. Oh, I want to do the histogram again because the building should show cyan. So I'm going to, there's a bug in this where I have to do this a couple times and then it will actually show the right color, and I don't know why that's a bug, but see how much brighter that is? So if I use what's called false color composite, that's what this is, vigorous vegetation shows bright red. The built landscape shows as this cyan blue color. And then when I zoom into here, I can begin to see cloudiness in the Potomac. But this gives me a very different view than the RGB. So I'm going to add a new data frame. And I'm just going to grab that down there. And I'm going to call this one, this data frame is my 432. And then I want to change this one back. Activate that. Properties. I'm going to change that one to 3, 2, no, RGB, sorry, 3, 2, and 1. And this is true color. Come on, and activate that. Okay, do you know why I can't activate that? Do you see the word activate in here anywhere? Oh, I'm clicking the wrong thing. There we go. So now I have, if I turn on this region of interest, and let's make that hollow, and I zoom in to that one. So there's true color, and if I turn that off and, oh, I need to have that there. Oh, I could do I won't do it though. I could pair these data frames so that they would match each other. Wouldn't that be useful? But I'd have to go remember how to do that. Okay. So I'm going to activate that, and then I think it was this one I was zoomed to. Yeah. So if I'm looking now at these two, and this is my true color, right? 3, 2, 1. Okay. So now I can kind of compare these two. I'm going to go to activate that. Oh, and see this field right here? When I go to activate this one, that's really bright red. So you can see what lack of vegetation there is in that inner city, right? One thing you'd want to know is what time of year was this? Because if it's tree off, if it's deciduous forest and tree off, it's going to look, you're not going to see that. In the summer, you might see a lot more. Insert, I'm going to insert another data frame. I'm going to add this down here. And then you can use the band combinations to look at the very different types of combinations that are used to identify different features. For instance, so let's do the 453, and that's supposed to really help with soil and veg conditions. All right, so we can look at that. Properties. No, not that, Lynn. Stop. There we go. Properties. 4. 1, 2, 3, 4. 1, 2, 3, 4, 5. Whoops, wrong. No, that's right. And then 3 would be red. Okay. Interesting. And I'm going to go back to properties. I don't know why this is not, yeah. So it does kind of show that, oh, now I see 2 different colors of vegetation, which I didn't see before. That's interesting. Yeah. So when you get to look at these on your own screens, they're really interesting patterns of vegetation. So they'll use this to look at snow melt, how much rock's exposed, what kind of rock it can be, what kind of vegetation. And then the last task is you're going to do what's called an unsupervised classification. So when I am looking at my multispectral images, the computer is using up to 255 color swatches. So let me go back to here, and let's put this in not the data frame, Lynn, this one. Let's put this in stretched. Yes, those are the only 3 color combinations I can make. And bands 1, 2, 3, 4, 5, and 7 are all 30 meters by 30 meters. Band 6 is a different resolution, so that's not included in your composite. I think it's like 100 and something meters. It's a lot bigger. It says so up here what that resolution is. So your composite band is really 1, 2, 3, 5, and 7. Yeah, that's 120 by 120 meters. The tricky thing is when I look at Esri, I'm going 1, 2, 3, 4, 5, and this is really 7, band 7, not band 6. But it will look like I've only got 6 options. So when you get to the third task, let me go back down here. So this is kind of exploring everything. You're going to try to classify the data into, where's my types? All right, where does it go? Yeah, so you're going to classify this into, at the end, you're going to end up with every pixel being either water, tree, grass field, street, or building. Okay, so you're going to take all of these and turn them into one of those other things. So we're really simplifying, right? And we're kind of generalizing. And so in the blah, 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 come on, do it. Toolbars. Oh, ArcMap is not responding. Okay. Spatial Analyst. You're going to go to, where am I going? Not reclass yet. You will do that. Okay, hold on. Maybe it's not in there. Let me look. Where am I going to turn on the image classification bar? Ah, wrong. Not a toolbar. It's here. It is the image classification toolbar. Okay, and so. Okay, so let's say this data frame 2 is active, and I'm going to classify this. I'm going to use what's called an ISO unsupervised classification. And I'm going to start by saying, okay, break these 255 colors into 40 groups. So I want to do 40 classes to start with. Okay, and I'm just going to let this go to the default, but you won't do that. You'll save it in your geodatabase, or when you set up your results, it should show up. So when I convert this into 40 classes, I'm going to get no longer a composite image. I'm going to get a raster with 40 classifications, 40 different colors. And that might be enough for me to be able to say, oh, pink and blue are water, yellow, red, orange, and gray are grass. So we're going to just kind of look at that. And this is kind of where that art comes in, where you have to kind of go back and forth between the image and your raster. Look at the golf courses. Can you guys see that? There's 1, 2, 3, 4, 5, 6. Ah. It's Washington, D.C. Well, it's that whole... Okay, are you not working, or are you just thinking? I think it's just thinking. I can't tell if anything happened. Okay. ISO classification. Did I not say save? Maybe I didn't say okay. So anyway, I did this at home and it worked fine. 40 classes. I'm going to put it on the desktop. No, I can't put it on the desktop. Shoot. Maybe it did work. Okay, well, let me see. I'm going to navigate to my to the desktop where the data is. It looks like it did do something. Okay, desktop. There's my copy of that. Output, I'm going to go in here and I'm going to call it class 40. So I know that I tried to do 40. Let's see. Man, I do not see anything happening. I'm not getting any message or anything. Maybe. But usually it won't let you. Okay. Some days I hate this computer lab. All right. Huh. All right, I'm going to see if it's maybe in there. Huh. Nope. Oh, something's thinking. Oh, okay. There's my ISO classification. And I want to symbolize this in unique values. So I'm going to have 40 colors. Okay? Ooh, look at that. I can tell that a lot of the water is this mauve and this blue, right? So if I turn that off, I can see that. That shows up different right over here. So I can't really distinguish things too clearly with this. So I'm going to try it again with 30 classifications and wait for an hour. Okay, and I'm going to put it right there, class 30. Okay. It wasn't doing that before, was it? Do you see the processing? I didn't think it was doing that either. Okay. So this is the iterative process. Ooh, there's my 30. Oh, that looks clearer right there, but let's go to, oh, which one was that? You know what? It's still doing it. That was my second attempt. That's how long that took. Okay. I did 3. Yeah, so that was my first one. All right, I get it now. So this should just be the same as the other. Turn it off and I will wait. Okay, so once I get this into 20, 30, 15 classes that I can distinguish, then I'm going to go back and use the raster reclassification. And I'm going to look at this and I'm going to go back and forth between the images and I'm going to say, okay, 1, 3, 7, and 12 are water. 8, 11, 15 are buildings. And then I'm going to run the reclass. And once I do that, then I've got the ability, here we go. Let's take a look at this one. Unique values. So this one is only, oh, that's looking a little better. I can see the water a lot better, and I can see, what's interesting is I can see water that's cloudy. So this is clear water, that's cloudy water. So if I wanted to know how much runoff was happening in the Potomac or where sediment was high, this would be a great way to do this. What do you think that bright pink is? Let's look and see if that's, oh, that's vegetation. Okay. So I've got vegetation. Good vegetation is this bright pink. Yeah. Okay, so that gray and that green look more like roads or built landscape. So that's the process. So then you're just going to go into raster analysis, and you want to try it with 20 as long as we're just spending time here. Which is which? Yeah, yeah. And so toggling on and off, so I can say, all right, I'm going to zoom in to this blue right here, and I'm going to toggle. I want to look just at this brown square. And sometimes I even put, oh, well, that's a tree. All right, that's vegetation of some kind. And this maroon is water right there. I could see that. But what is that big purple thing? Oh, that could be a building. So that's what you're going to do. You're just going to hunt and peck. You're going to create a chart then at the bottom, or on an Excel, that says, where did it go? Do I have that? I think I closed the lab. Shoot. I hope it's in here. Yeah, you're going to create this Excel table that says, okay, my number 1 is water, my number 2 is water, my number 3 is water, my number 4 is water, and I'm going to give those a new number, right? So all of those are water. So when you get ready to reclass, you're just adding a 1 into all of those things, and then you're going to end up with just 4 types of rasters, which then you can calculate how much area is water, how much area is vegetation. Then I want you to reclass all of that into permeable and impermeable and water. And that is the process that people use to determine heat islands, to determine how much runoff, what's the impermeable surfaces. So you're going to take 255 reflectant images, right? Pare that down into 30, 20, whatever works for you, and then pare that down into 5 classes, and then pare that down into 3, right? So you're going to have kind of taking that. Now, the benefit of this is that you could do this at a state level. This would be really hard to do, to go out and measure everything and figure it out on the ground, right? If we want to do the campus, we could do the campus. We don't need remote sensing for the campus. But if I want to do this greater Washington metropolitan area, or I want to look at sediment along the Amazon, this is the way that's being done.